This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Please give her a big applause.
Thank you, and that's my pleasure to be here with you today. I have only 30 minutes. It's very, very small amount of time for me. But basically, what I would like to start today is I would like to introduce you to Azure AI technologies. And first of all, what we need to emphasize is that we are talking about the technologies that are already globally used by a lot of companies. So we are not talking only about some type of technology which is on the research or that someone is just testing. No, those technologies are already used by multiple organizations, including enterprise organizations. So it means that it's working and it's worth to know them. And if we want to grasp, let's say, big picture of what we are talking about, we are talking about, I think at that point, more than 60 APIs integrated into different Microsoft products. I would like to focus on those which are platforms as a service. So it means that you as a developers, you can integrate them or use them to build your own products. And basically we can think of them as the one type is so-called Azure AI services. So for example, those are pre-trained models. For example, Azure AI Search for retrieval augmented generation. Or if you maybe remember from the previous marketing positioning, Azure cognitive services. So under the umbrella of Azure AI services, we are now thinking about those APIs. The second part is Azure Machine Learning, and this is basically the big MLOps platform. It is dedicated for data scientists or Azure or artificial intelligence developers who are building their own architectures of the machine learning models and would like to train them. So that's one thing. I will not focus a lot about that today, but it's worth to mention. And of course, because as I said at the beginning, Microsoft would like to support also high-level enterprise, best-in-class, most highly demanding companies. Microsoft is also building tooling around something that we are calling compliance, responsibility, monitoring, all of that, whatever you can name, is also available. And also what is available is something which is called Azure AI Studio. Azure AI Studio is basically the web application. It's a platform which helps you to start building your software products, because normally you just need, maybe not just, you need to design the architecture and integrate multiple APIs. And this is totally not an easy task. So to help you start, but also gain first MVPs, POCs, even go into the production, Azure AI Studio can help. But you can see here that there is word foundation models. So what we are talking about, what is the foundation model? Basically, foundation model is a model which is able to use multiple different types of data sets. So those data sets can be text, images, speech, which means this is the sound. It can be structured data. It can be 3D signals. Multiple types of data are then used to train so-called foundation model. And we are also using here a concept of transformer. Transformer is a concept from machine learning, basically. And with current, let's say, adaptation of generative AI, the transformer is actually used in the natural language processing regarding text tasks. But previously, in much earlier era, transformer were infused into the speech models. So this is something that how we can think about foundation models. And then, thanks to that, thanks to the multimodality regarding the different types of data, we are able to use one foundation model for different so-called natural language processing tasks like question answering, sentiment analysis, information extraction. Because before the era of foundation models, we needed to have separated machine learning models in natural language processing for each of the tasks. And when we have that foundation model, we are having one architecture, one input, one API, which is, for example, input of GPT class models or any other type that currently we have hype on. And basically, inside of its own architecture, this model is able to somehow, based on the prompting that you are providing, based on the prompts that you're writing, differentiate, okay, what is your intention and actually what you would like to extract from this. And this is why we are now have an era of prompt engineering, because we basically are having these fantastic foundation models, but we need to be able to somehow communicate with them to get what we want from them. And when we are talking about generative AI, which is basically about let's generate a text, in that context, we are thinking about language models. And maybe you heard about so-called LLMs, large language models, or SLMs, small language models. So before we go to large and small, let's understand what is the language model. So basically, language model is a specialized type of machine learning model that you can use for performing natural language processing tasks, like determination of sentiment, or summarization of the text, or comparing multiple text sources for trying to get the similarity of those texts. And of course, generating new natural language. And what you can see here is conceptual architecture from one of the relatively new publications. How we can think of what is inside such a language model. So basically we have multiple layers of neural networks, different types of neural networks. Those architectures could be very, very complex. So if you are interested in going deeper dive in this type of topics, my recommendation is go to the publications. This is what I am doing, and this is how I am learning. So that's the way. If we would like to try to a little bit make it more easy. So the most important parts of this language model is at the beginning we are having data, and at the beginning we are having something which is called encoder. And what this encoder is doing, it is creating semantic representations of the training vocabulary. We are also having here the concept of embeddings, which are vector representations, numeric representations of the words, and magic is happening inside. And then at the end, we have the decoder. And the decoder is basically decoding something, some type of numbers, matrices of numbers, to meaningful sentences for the humans. So the decoder is basically generating new language sequences. And the basic concept, if you would like to better understand language models, is first of all tokenization. So tokenization is converting language into some type of tokens. That's so to the numbers, right? Because computer doesn't understand the text. We need to translate it to the numbers. We are also having dense representations of the words, which we call embeddings. And basically, how we can think of that, if you are familiar with vector spaces from physics, for example, embeddings are this kind of vectors in the vector space. And based on how they are performing in that vector space, it represents the meaning of the words. So that was very, very, very important breakthrough to discover first algorithms to obtain that. And the third mechanism is attention. And okay, so once we more or less understand what is language model, why we are talking about large language models. So, okay, maybe you can feel that they are quite big, but what does it mean that they are big? It means that in 2018, BERT language model had 345 million parameters. Now we are going into the billions and trillions. So you can imagine that hosting this kind of model, even if this is optimized, even if this is serialized, to perform inference on such a model, you have to have a big compute, you have to have a kind of huge cluster. And this is why, for example, when you would like to have large language model, it might be a little bit hard for you to just download it and host on your mobile device. So this is why we are trying, or humanity is trying to think, okay, are we able to optimize that, to make those models a little bit smaller, to make it more flexible, maybe cheaper, maybe adaptable to different situations like inference on the edge. So yes, there is a concept of small language models, and it means that they are the most important parameter here is the number of those parameters. But basically, small language models are much more cost effective, but also they are giving you the deployment flexibility. So for example, it starts to be possible if you would like to deploy that model for the inference on the edge or on the mobile device without basically connection to the internet, to have inference through the cloud. And the most common use cases of SLMs then may be situations where you have no connection to the internet, or where you have resource-constrained environments. I think the most common use case might be, I would like to have no connection to the internet and not connection to external data center. And coming back to Azure, so Microsoft has something which is called Model Catalog. And Model Catalog is basically part of the Azure AI Studio that I showed you before, but also Azure Machine Learning. And there are two types of models. There are models that has to be hosted on the cloud because they are large and because, for example, Microsoft is collaborating with companies to bring that IP into the cloud. But there are also models that you are able to deploy on virtual machines on the cloud. So we have models from the Azure Open AI service, and this is part of the cooperation with Open AI company. We have models from Hugging Face, from NVIDIA, from Meta, from Mistral, and we also have, for example, Phi models. Those are SLMs. So what is really amazing about language models, whatever, if we are talking about LLMs or SLMs, I will be using since now abbreviations, is that they are able to generate content which is meaningful to the humans. And that's pretty amazing because it makes us believe that those machines are thinking. But this can be very, very useful when we would like to, for example, perform some tasks over very big data sets, or we would like to accelerate our work. And sky is the limit. We just need to have some idea how we can use that and just try it, right? The second very amazing thing is that those models are, or the newest models, let's say, are multimodal, which means that you are able to have one model which is able to generate for you text, but also generate for you images. Or when you're sending the image and asking what is on that picture, then that model is able to describe you something. So once again, sky is the limit. Also, the newest models are also having the feature of video to text. So you are able to upload video and get from one model to get insights. And also customization. So I think the most common and the First scenario that I am observing is that companies are having their internal documentations about their systems, internal, external, and they would like to somehow make it more easy to go through those documentations. So the first use case may be, okay, I have big data set about my custom something, so it is definitely, there is zero possibility that generative AI model was trained on that data. So how I can basically make this model be able to use that data for me to be effective. Another perspective for you to understand is that there are two types of, or two perspectives: model as a service and model as a platform. Model as a service means that you are not deploying the model, you do not have control over that. Basically, you are deploying the whole service like Azure Open AI service, and it is exposing API, REST API, and you are integrating with that REST API. Model as a platform means that you are able to pick the model and then you are responsible of deployment of that model and maintenance of that model on the virtual machine. So in this scenario, from Azure, you are mostly using just the virtual machines. And depends on the situation, depends on your scenario, two different options may be useful. But this is very important to differentiate, because you may ask, okay, why I cannot deploy Azure Open AI GPT-4o Mini into my virtual machine on-prem, right? So because that model is served only as a model in the financial model, which is called model as a service. Okay, so going further, let me show you this.
Welcome to Azure AI Studio, the place to build and deploy your generative AI apps at scale. Explore out-of-the-box and customizable APIs. In the model catalog, access cutting-edge models from Microsoft, Meta, Mistral, Omniface, OpenAI, Cohere, and more. Use model benchmarking to identify the best model for your use case and needs. Customize models with advanced fine-tuning and ground your models on your secure data using retrieval augmented generation. Craft your workflows with flexible orchestration tools. With tracing and debugging, monitor each step of LLM flows, including latency, token usage, and model errors to quickly debug your app. Choose where and how you want to develop with code-first experiences and integrations. GitHub code spaces, VS Code, Lightchain, and semantic CUDA. Measure and improve app performance with manual and automated evaluations. Azure AI Studio is equipped with built-in configurable content filters, responsible AI tools, and practices. Deploy at scale with continuous monitoring of production, and manage your app with Azure Enterprise Controls for security, privacy, and compliance. No matter what your generative AI application may be, you can build it here. Build with Azure AI Studio.
And two questions. Answer the first question: if I am using this, yes, I am using that. This demo as a video is because of the, let's say, time constraints. The second question: if you have to pay for that, no, you are not paying for Azure AI Studio. You are paying for the resources that you are using within the Azure AI Studio. So another thing that's pretty cool is that, maybe you heard, maybe not, Microsoft is collaborating with OpenAI company and is bringing OpenAI intellectual property, which are, for example, GPT class models, into Azure through Azure Open AI service. And let's say, what is the newest, the freshest status of what types of the models are available in Azure OpenAI? Because maybe you know that OpenAI is still advancing all of the research. So, of course, there is some delay because Microsoft needs to collaborate, basically. But what is available now? So, from the language perspective, we have GPT-4, 4 Turbo model, but also O1 in preview and O1 mini models. Regarding multimodal models, there is available GPT-4o and GPT-4o mini. GPT-4o, 4o Mini, GPT-4, and GPT 3.5 Turbo are available for fine-tuning. There is also a specialized model for images, which is DALL-E3, and specialized model for transcription and translation, which is called Whisper. But this is not the only one model for translation. This is speech to text. Because this is there is dedicated speech service on Azure too. And why this is so cool? Because now everybody would like to integrate that with application, because AI basically is a feature in bigger system. So what we are trying to do is, okay, let's imagine what basically feature we would like to bring to the application, and then how to do that. So those of you who are building applications, you know that there is building life cycle of application. CI/CD, DevOps, things like that, boring stuff, right? Sorry, but this is very needed, because otherwise we are not able to bring and maintain software on production, right? So actually integrating, even not building, but just integrating LLM or SLM model into the application brings new challenges to that. So there is a specific process that we can think of. That first of all, we need to define the use case. This is the initialization phase. Then we are going into the experimentation phase, where we are testing, we are building flows, what this data set, what this LLM should do. We are building prompts. We are building prompt flows. We need for that maybe some framework. Guess what? We have framework which is called prompt flow, and guess what? It is integrated with Azure AI Studio. Actually, it was showed on the video. Then we need to evaluate this situation, and if the results are pretty cool, we can bring that into the production. So for those of you who had experience in machine learning, you may feel like, okay, it looks like kind of machine learning stuff. There are similarities, there are differences. What's important here to understand is that there has to be cohesion between development team, app development team, let's say classical app developers, but also those people who are building prompts, and they need to collaborate together. And now when we think of, okay, how to bring domain knowledge to LLMs, so the use case that I said at the beginning, the most common use case. One thing, we can build prompts and do prompt engineering. Second thing, we can do fine-tuning. Fine-tuning is retraining the models on the data sets. There is also a special pattern which is called retrieval augmented generation. So retrieval augmentation means that we are having external databases, external knowledge bases with data, with search capabilities, like maybe you know Elasticsearch or MapReduce, things like that. So things kind of like this. And then we are retrieving information automatically through built-in processes within the application through that external knowledge. And when we think about that retrieval augmented generation, this is the most common pattern. It is already on production with many customers. I am also using this with the customers that I am working to. We are basically building that. So how it looks like conceptually is that, okay, we are having external data sources and we need to have some type of retrieval system. So I said that Elasticsearch, for example, this is the most common open source, is it open source? I don't know, outside of Azure technology. And on Azure, for that, you can have Azure AI Search. Then we are having service with language models. Those can be large, can be small, then can be hosted on Azure, can be hosted wherever you want. But basically, we have separated microservice for that. And then we have some type of orchestrator. This is normally the backend of application. And this orchestrator is basically getting from application UX user question and is responsible to understand what's happening and what to do, if that question should be sent here for, I don't know, generating dynamically embeddings, if this should be then sent to retrieval system. So that's basically the orchestrator. And this orchestrator can be built from semantic kernel, LangChain, prompt flow, and maybe other frameworks. But the key point here is this retrieval system. So you can use on Azure AI Search, and maybe you remember, I have even sticker here about Azure Search. So Azure AI Search is the oldest technology, AI technology, and it is still developed. The name is changing. There is a lot of new advancements put into that technology. But basically, now product group was and is still working on increasing the latency, increasing the vector capability, the support for that technology to be your vector database. So for example, other very popular vector database is Pinecone. So Azure AI Search can serve you with that. And Azure AI Search can be integrated basically with whatever. And there are very good integrations with other studios, like, for example, Azure AI Studio. And why it is important is that the quality of what end user sees on the front end really is related to what is your retrieval strategy, because based on the quality of that retrieval, you can bring proper or not related information. And with Azure AI Search, you can have keyword search, vector search, hybrid search, which is combining different strategies. There is also special algorithm which is called search re-ranking. And unfortunately, I don't have time to go deep dive into that, although I would love that. But this is really pretty good, pretty interesting to go deeper. There is integrated vectorization, and just the glimpse from last build is that there was high increase in vector density. There were also increases in storage limit, more compute capacity in most tiers of the solution. So basically, if you would like to go with RAG and if you would like to test it on Azure, definitely try this solution. But beware, it's not so maybe not. It's easy to start, but it takes a while to learn how to really use that and make it perform. So I heard a story from one customer that once that is from, I don't know, 3 or 5 years ago. But once they onboarded them into at that point, it was Azure Cognitive Search, it took them a year to optimize it properly, to perform on the level as they wanted. And there is also a very interesting research project, which is called GraphRag from Microsoft Research. If you're interested, if you go to the aka.ms GraphRag, it will prompt you to the basically landing page for that concept. And what that research group discovered is that, first of all, whenever we are talking about private data set, is that data set that model was not trained before. So there are specific challenges whenever the data sets are very, 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 very big, and there is challenge to answer that question. And also, whenever there are more abstract questions, like catch me up on the last 2 weeks of emails. So, of course, RAG has its limitations, but what this research group in Microsoft actually what they proposed is let's use LLMs to build knowledge graphs. And this is what about the RAG graph is. So basically, on the first phase, LLM is processing the entire private data set and is creating references to all entities and relationship within the source data. And then this is used to create LLM-generated knowledge graph. And if you're working with graphs, this type of stuff, this is basically way of illustrating that in 3D space, right? Then this graph is used to create a bottom-up clustering that organizes the data hierarchically into the semantic clusters. And basically, then whenever we would like to do the inferencing, the whole system is using that knowledge graph. And very fastly going through the examples. So that research group used VINA dataset. All of that I am showing is accessible publicly, so you can go to the aka.ms/graphrag and find it. And you can see the differences how baseline RAG, so this classical approach versus graph approach, is differentiating into the performance regarding a very big and complex data set where a lot of exclusively connected informations. So when the question was relatively easy, what is Novorossiya, then both approaches let's say replied. But for example, when the question was more abstract, what has Novorossiya done, which was much more difficult, especially regarding the data set, you can see that baseline RAG did not perform, whereas GraphRag proposed some type of response and also elaborated a lot. Also, when the question was more abstract and needed to go through all of the data set, like what are the top 5 VMs in the data, then baseline RAG performed more or less okay, but GraphRag performed much more extensively, much more detailed, and probably much more accurate. So this is the still research project, but it is available on GitHub. I didn't have time to test it, but I will definitely do that, and that's pretty interesting. I said that you may need to build the chain of prompts, and the first framework that was built for that is LangChain. It supports, as far as I remember, Python and JavaScript, if I remember correctly. There were no such technology for C#. So Microsoft introduced framework which is called Semantic Kernel and is still in the development, but also another framework is called PromptFlow. This is basically the Python framework. It is open source, it's on GitHub. You can have it installed on your machine without any cloud. I, for example, have it on that beautiful machine. But also what is important is that it is pre-integrated in Azure AI Studio. So this is one of the screenshots that how it may look like. So you're basically, through the special type of language, you're scripting the separated parts of the whole flow, but also you have visualization in the graph how the flow is interconnected, because basically whenever you're building this type of prompt engineering projects, what you're building actually is this type of graphs. Another just glimpse, but a lot of Azure AI services can be served in containers, in Docker containers, which means that you're able to deploy them on-prem. And this is very important for the scenarios when, for whatever reason, you're not able or you don't want to have to serve model in cloud. Unfortunately, as I said, we do not see LLMs here, but I hope that you understand now why. But there is also offering related to the disconnected containers, so definitely it's worth to mention and be aware of. And 2 things at the end. Regarding text-to-speech, This is pretty cool. I don't know if you heard about avatars, because Microsoft is not the only company which is doing this. But basically what it means is that you have predefined, some of the predefined avatars, you are able to define, for example, even your gestures through SSLM language. But those avatars are also multilingual and there are different voices with different languages. So Microsoft Speech is supporting, I don't know how many, more than 100 languages, very easy. So basically what you're able to do is that you're able to build your custom avatar, or you're able to build front-end for your bot, which will be talking in many languages with human-like face. And there is also a feature which is called custom avatar, which means that you're able to upload your recorded video, for example, me, Ula, and I will be that avatar. So then we will need to train the model, and we will be able to have Ula as an artificial intelligence. But this feature is limited, so you need to fill the form, and you need to be accepted by the product group. But there is an interest. I need to say there is an interest in that feature. And also the glimpse at totally the end. A very interesting scenario that I'm observing is intelligent contact center, because with LLMs, with multiple services, this is also, by the way, publicly available. So Microsoft is having something which is called Azure accelerators. So those are the pre-built architectures and configurations that you are able to use in specific scenarios. And thank you. Thank you. And if you have any questions, I am now yours. Thank you so much.
Thank you, Ula. Big applause. Are there any questions? Okay, so if not, Paweł now will give you some statue. Okay.
Oh, okay.
Again, thank you, Ula, so much.